This is Hua Jenny, can also call me Zohar. I'm a master's student from Nagoya University, and today I'm so glad to share with you my study is telling about the real estate investment and the regional economic development in China. And on this study, I'm going to use a kind of spatial econometric approach, and I will go through my presentation by this: the background, introduction, literature review, the research gap and the research objective, data methodology result, and the conclusions. The first is the background introduction part. Say real estate investment plays a very important role among the investment because of those reasons: the lack of liquidity, the large size and the long business cycle, and the high transactions cost, and the solid up and downstream linkage. The real estate investment and may also affect the economic development by many ways. For example, the employment, saving, total investment, and the labor productivity. And regarding of those kind of features of the lacking of liquidity and the large size, so improper decision may cause a very huge resource misallocation. So it is also taken as a kind of essential policy tool by the central government or the local government to release the policy and to accelerate the economic growth. And in China's case, from 1998, the Chinese government decided to transform the real estate from the society planted oriented real estate, which is the construction, the maintenance, and the management is all on and into the market oriented real estate, which is that allowed the free trade among the private sector, which directly accelerate the development of the real estate in China. And then the fast development in real estate sector is associating with the development in GDP. And they're sharing the kind of similar dynamic movements. And here we can see from this figure, the line in gray dashed line is showing the growth rate of the real estate investment, and the one in solid blue line is the growth rate of GDP. Actually, from 2001 to 2017 until 2014, they have a kind of similar movements. And also notably, before 2014, the growth rate of the real estate investment is much higher than the growth rate of GDP. So this kind of rapid growth rate of real estate may also result in a kind of imbalanced, which could hinder the development of the national or the regional economy. And also the growing of the real estate investment has a kind of same spatial distribution with GDP. Then I will explain that and move to the literature review. Here, the Han is the first people who learned how real estate investment shaped the regional patterns, and then pointed out that a very huge disparity exists between the coastal area and non-coastal area of China. And then soon continue to learn about the relationships between the construction industry and economic development at the regional level. And but after that, this kind of topic direction turned to a kind of causality discussion between the economy development and the real estate investments. But most of those studies has this kind of limitation because despite the solid spatial characteristic of real estate and the real estate investment, almost a less study have learned the spatial correlation of the real estate, and most of the studies are using the kind of province level data. But actually inside the province, this kind of disparity is still huge. So in order to fill this gap, this paper is going to use firstly, ESDA to study the spatial pattern of the real estate investment and the regional economy, and then apply the MGWR model to study the impact the impact heterogeneity of real estate investment on the regional economy. And also for the data issue, this paper is going to use the city level data, which including 295 cities out of like 344 in total in China. The objective of this paper is trying to find the spatial characteristics of the real estate investment and economy development, test their spatial correlation, and most importantly, to find out whether they have a kind of similar pattern or not. And secondly, to study the effect heterogeneity of the real estate investment on the regional economy. And the data usage, for the data usage here, I will use the GDP per capita as the Y variable to explain the regional economy development, and then the real estate investment as the X variable, and then the last 5 variable as a control variable, including the labor force participation rate, the urbanization, tax burden, the population density, and the share of the secondary industrial to the GRP. Here, GRP is the gross regional products, and all those data is are collected from the statistical yearbook of the Chinese cities. And like first, let's look at these two maps. It is the quantile map for the GDP per capita. The left one is in 2000 and the right one is in 2018. Let's see the difference between these two maps. In the left one, see, the darker the color is, the larger the amount is. And from the left one, we don't see like very significant dots, like telling that, oh, this area is super developed, but other place is super lag behind. They are kind of like average. But in 2018, we notice here in Beijing area, here in Inner Mongolia area, here in Beijing area, here in Shanghai, Shanghai area, and here around like Guangzhou, Hong Kong area, they're beginning like getting much more developed than other places, and also some outlier have like begin to exist like inside the inner China. And let's move to the real estate investment part. The left is the data for 2000 and the right is the one in 2018. And the one in 2000, we can also see the same pattern with the GDP per capita. They're kind of average, no much area is too significantly higher, or no place is significantly too low. But in 2018, we can see like some places grow too fast. For example, here the Beijing, and here Shanghai and Chongqing, and here is the Guangzhou and Shenzhen. They grow faster, much faster than other places, make them like significantly higher than other places. And the methodology here I'm going to use, firstly, for the first part is the ESDA, the exploratory spatial data analysis. And it includes two parts. The first one is the Moran-Sai test. Moran-Sai is a kind of index testing the spatial autocorrelation. And here is the formula. And like notably here, the weight matrix is essential. And the weight matrix decided like whether they this city in this calculation, they will include this city as a neighbor or not. And for the spatial weight matrix, there are a lot of weight matrix. Like here, I would like to introduce few. The one is the k nearest neighbor weights, which means, for example, I set k equals to 8, which means I select a sample city, and I will selected the 8 cities which near this city the most as their neighborhood. Like if I treat it as a kind of as a neighborhood of this city, I will set the weight matrix as 1 and others as 0. And second is the contiguity way. It's easy to understand as long as we share in the same boundary, and I will set our weight as 1 and others as 0. And last is the inverse distance weight. The longer the distance, the weaken the influence. And the interpretation of the Moran psi is like, first, when Moran psi is larger than 0, meaning that there is a kind of positive spatial autocorrelation exists, which like in kind of easy explanation is, for example, I'm good student and my desk mate is also good student. We influence each other. We have a kind of positive influence to each other. That means that we have a positive like autocorrelation. Also, in other hand, if I'm doing bad on my study and my desk mate is also doing bad, and that's also a kind of positive like spatial autocorrelation, meaning that if I'm good, my neighborhood is good. If I'm bad, my neighborhood is bad. And when Morans are like less than 0, meaning that there is a kind of negative spatial autocorrelation, is the opposite with the story I told just now. Like, for example, I'm doing good, but it will influence my desk mate, make his study worse. That's a kind of negative spatial autocorrelation. And when a Moran psi equals to 0, meaning that there is no autocorrelation existed, the distribution of those location is kind of like random. And the second part is Lisa. When we already know like there is a kind of spatial autocorrelation exists, but you cannot exactly tell like where those places, significant places exist. So Lisa here, local indicators of spatial association is going to tell us. The first is the result of the Moran psi. And here I use the two kind of weight metrics to test their Moran psi. One is the queen contiguity, and second one is the inverse distance to test both GDP per capita and the real estate investment from 2000 to 2018. And I removed 2017 because of the data limitation. And by prioritizing the p-value, so I finally decide to use the queen contiguity to conduct my study. The value in the comma is the p-value. So actually, let's look at this line. The value is all above 0, and we can even have a take an eye on the tendency. It is becoming larger first and then shrinking down and then growing again. But actually in overall, this kind of spatial autocorrelation is getting stronger. And then move to the real estate investment. Let's see here, the p-value is relatively lower than the GDP per capita, but it's also showing a kind of increasing tendency from 0.02 to 0.142, meaning that actually during this around 20 years, this kind of spatial autocorrelation is getting strong as well. And then it's the result of the Lisa telling us like where exactly those kind of significant places exist. And here's some the meaning of those color. The red color meaning that, for example, here is Shanghai. Shanghai is performs very well on its economy, and also it has a kind of positive influence on its neighbors, which bring in their neighbors growing as well. So like we also call it high, or we call it hot dot. Like I'm doing good and I also help my neighbor to become good. And the color blue meaning to the opposite, I'm doing bad and I'll bring my neighbor city worse as well. And the color of the light purple meaning that, oh, I'm doing bad but my neighborhood is doing a good job. And the pink color meaning that I'm doing well but my neighborhood is kind of like not so good. So like the for the left part, the left figure telling the GDP per capita in 2000, and like those area, only those area around like Shanghai and Fujian and here in Guangdong, Guangzhou is the hot dot. They have the kind of like good spatial autocorrelation to their neighborhood, but to the west part, those like poor area clustering together. But when time go to 2018, we see like those kind of clustering become larger, and the influence of like Shanghai area, it is getting large. And so as like here, Shandong province also have like very good tendency of being good together. And like here, Chongqing province doing very, very good, like on its economy, but like its neighborhood is kind of like out lagging behind. And so as those like cold dot is also increasing, meaning that actually between these 20 years, the rich area become much more richer and much more clustering, and the poor place, they're more likely to cluster together. And then is the result of the real estate investment of in 2000. It's kind of like similar with that in the for GDP per capita, only some hot dots located near Shanghai and Guangdong, and some cold points around here. But luckily, like west area is not so clustered on its real estate investment. And when time go to 2018, this kind of cluster become more than before. And like those area also like had cold dots cluster together. So this is for the first part, to find out the kind of similar pattern, spatial pattern of the GDP per capita and real estate investment. And here we can make a rough conclusion is that they're sharing a kind of like similar spatial pattern developing in the east, and like less developed in the west. And for the second part, I would like to use MGWR, the multi-scale geographically weighted regression, to taste the relation between the real estate investment and the GDP per capita. And before go to MGWR, I would like to introduce GWR, the geographically weighted regression, a little bit. Actually, this is a kind of spatial regression model based on the OLS. And just look at this formula. When we remove this beta, the comma, UI, and VI, it is exactly the OLS. And the result of the GWR is going to give me, for example, in my study, I have 295 sample cities, and it is going to give me 295 coefficients telling the impact of the real estate investment on the GDP per capita. But the only difference with the OLS is the GWR is you don't need to use a kind of time series data. For example, OLS, you have to use a time series to help you to find out like those 295 coefficients for each city. But GWR, it has a kind of typical things called bandwidth, like grouping those cities around you as a kind of bandwidth, and they group those data together and run regression, and then will give you a result on the coefficient to tell the impact. And here the summarized statistics for my control variable and X variable. And like before going to the regression, I do the variance inflation factor test to trying to make sure there is the multicollinearity problem, and the result is pretty good, all below 3. So like next, moving to the MGWR. And if you remember, I mentioned like it will give us like 295 coefficients, but here for better understanding, I just pick the mean value of the coefficients here. And in real estate investment, the impact is 0.315, is relatively high, and the labor participation rate is also high, and urbanization is also like significant, and those for tax burden is negative, yes, reasonable, and the population density minus, yeah, reasonable, and the industrial the share of industrial to the GDP is 0.386. And in order to make the result more visible, I mapped the coefficient into the kind of map. And here, the left part is the coefficient of real estate from the MGWR model, and the darker the color is, the higher the coefficient is. And from this map, we can clearly see that, in fact, the east part has a much more like impact on their like GDP per capita, and for the west area they have a kind of like relatively lower impact on their GDP per capita. But when we look at the value, actually they're all above zero, meaning that so far no negative impact on the GDP per capita. And the left part is the p-value, but seeing the value all below zero, all around zero, so that's just perfect p-value, meaning that it is trustable. And last, the conclusion that for the first part, the spatial dependence on the real estate investment in the regional economy, they are getting stronger. And the second, the spatial pattern of the regional economy and the real estate investment is gradually become similar, and both are developing the east and some of the capital cities of each province and the key cities of China. And while doing a kind of poor performance in most of the middle and west area. Three should be three. According to the result of the MGWR, we know the real estate overall is contributing to the regional economy, but differ by the levels. And in the east area, a unit of the real estate investment increased can lead to a higher development on the regional economy than that in the west. For the coefficient of the real estate investment, we notice that they don't have a clear tendency of increasing or decreasing. It is like fluctuating up and down, but still like very significant to the regional economy. And sorry, but I think this sentence is for my previous study. I forgot to remove them. And yeah, that's all. Thank you for your kind watching and listening. And any comment and question is welcome. Thank you.